All right, so I guess I will get us started with a few kind of organizational comments. While there might be one or two more people coming in. So this is supposed to be a discussion, right? So we'll try to have a good discussion amongst the panel. I think we have a very high-profile panel here. Thanks to the three of you for joining me today, this morning, wherever you are. The idea is to have a lively discussion, and to all participants who are already here, welcome. Please feel free to engage. You can either raise your hand in using the function in Teams, or if you're more comfortable, you can just post it in the chat. Your questions, we will then try to address them and get to them. As I said, we are attempting to discuss with my guests the current state and the developments in in-space mobility. So you cannot expect in the next hour kind of, teaching presentations. That's not what we'll do. We'll have a lively discussion. I will first ask the speakers to introduce themselves and their companies or organizations, and where they are, where they see themselves in this very interesting, very lively ecosystem. I think we can all agree that space is as exciting as ever, or maybe more so. And mobility is, to me personally, a very interesting topic, because it is kind of the key to master the sustainable uses of orbital resources. So that's why this is a topic that is very close to my heart, and I'm very excited for the next hour and this discussion. Please be reminded this will be recorded so that others can also watch it. There's a lot of events this week going on in parallel, so we want to have everyone, be able to follow this discussion. That means, if you ask your questions, they will also be part of the recording. But please do so. All right. Yeah, I guess let's get started. I will start in the order where I have you guys on my screen. This is Stefano first, Adel, and then Roger, if that's okay for everyone. Stefano, you're the VP for Business Development at Deorbit. Deorbit is, as you say, the claim on your website is the leader in space logistics and orbital transportation services. So you would definitely have a role in the ecosystem of in-space mobility. And I think a lot of exciting things have happened with Deorbit in the last 18 months, while during COVID. So if you can catch us up on where Deorbit is in this ecosystem of in-space mobility, and where your aspirations are, and where you see yourself in the future, that would be greatly appreciated.
Thank you, Alex. Thanks for, first of all, the invitation. It is indeed a very exciting moment for space, and we are living a very exciting year now here in Deorbit. We are, lucky enough to be able to start last year the first regular transportation service to space through our dedicated carrier called ION, which is the acronym for In Orbit Now. We are about now under 30 people, so we have grown fast. We exist since 10 years right now. We are based in in Italy, where we have the main manufacturing site, and the UK, Portugal as well. We are we are definitely actors in the space logistics. I think we will have time to talk about what space logistics means, but mainly everything that all these businesses that are developing in the space ecosystem using the space resource will need to have some kind of services, being transportation or moving goods from one place to the other, communication. They will need everything that we have on Earth for all our operational businesses, basically. And that's what Deorbit is trying to develop right now. In the past 10 months, we launched 3 missions, 3 ION missions. We carried about 40 payloads on board. And those payloads were CubeSats that we distributed in the right position in space. So actually we moved into the right orbit and we delivered the customer to the right orbit. And we transported also hosted payloads on board, both for in-orbit validation purposes, but also for operational missions. We want to expand this business model as much as we can. So we want really to develop a regular service, a little bit like you see for airlines. So to have regular launches, people being able to move from one launch to the other and so on. And also moving quickly towards the in-orbit servicing market. So being really able to move goods in space to create that infrastructure that hopefully will help other companies, other businesses, other organizations to develop their ambitions in space and ultimately to contribute to some of the welfare here on ground. Because at the end of the day, selling and developing space servicing also means benefiting to citizens on ground and helping them to have better services or different services that we have right now.
Thanks a lot, Stefano. Yeah, you touched on a couple of points that we want to discuss definitely. What in-space mobility actually means, and which part of mobility we're talking about. Adel, you are the CEO of Infinite Orbits. Infinite Orbits has started as a company to service geosatellites, actually, right, and extend their mission life. And also, you have had some, exciting years, I guess, in the past. And you recently took over the company as CEO. So I'll be happy to also hear about your aspirations for the company and how you see yourself develop in this ecosystem.
Yes, thank you for the invitation, Alexander. Yeah, I took this role about less than a year ago, but I'm an original founder still of the company. We started the company 3-4 years ago to do in-orbit services in general, starting by geo. Sorry, was there a question or just some noise?
No, I think it was some background. Sorry for that.
Okay, yeah. So we started the company 3-4 years ago to do in-orbit servicing in general, starting with geo and life extension, as you mentioned. But in general, the way we view ourselves as a company who will provide in-orbit services to assets who are in space. We really see space, geo or LEO, as an area full of assets that have different needs and that have market values. And for this market value to continue, these needs to be met. It's actually like providing maintenance services to any industrial asset or plant on Earth. This is how we view our mission. We deliver services to assets who are in space. In terms of technology, what we develop is autonomous navigation for assets, because we believe that to service the assets that are in space, you need very smart navigation and you need a high level of autonomy around this navigation. I'll be happy to elaborate a bit more on that, but to effectively service at the right price all these assets, you need to be highly mobile and you need to be able to execute this mobility in an autonomous or semi-autonomous manner. Otherwise, the costs associated with servicing such assets will be just too high and not compatible with the market value of these assets. So this is what we are here for. We're living exciting times. We're preparing for 2 GEO mission next year, hopefully a LEO mission in the year after, 2023, and fully commercial life extension services in 2024.
Very exciting. Thanks for the brief introduction. For all those who have recently joined, we are just starting. We are just in our first round to place our very esteemed speakers into the ecosystem of in-space mobility. And then we will continue with the lively discussions. If you want to prepare questions, for our guests, please feel free. And we will get to them a little bit later. The last guest on our panel, Roger, thanks a lot for agreeing to speak with us today. Roger just gave I don't know if any of the audiences saw it, but gave a very interesting talk about autonomous operation in space just yesterday. And I think it's a very good segue to our discussion right now. Roger, obviously, I think the role of ESA, in the whole ecosystem is fairly well understood to support industry and progress of technology. I think your very broad overview of the industry in general and what's going on is extremely interesting here for this panel. So I would like to kind of ask maybe from a different perspective, but still the same question. Where do you feel like the ecosystem of in-space mobility is right now? And what are the kind of, is there major trends you see? Is there things that you anticipate for the future that we can then engage? Welcome.
Yes, thank you, Alexander. I think, well, thanks first of all for the opportunity to participate in the discussion here. Indeed, so I'm head of the CubeSat Systems Unit in the Directorate of Technology, Engineering and Quality at ESA. And, my main job is to develop and launch technology demonstration CubeSats, so nanosatellites, which are, let's say, we work closely with the industry, which are developing the CubeSats, and we are of course acting as customer and performing technical management on the projects. And actually we have a lot going on. I think we can see also in general the CubeSat industry and the small satellite industry in Europe, but also other parts of the world, is really taking off now, and there's really a lot of activity going on. We are of course trying to, as you said, support our industry in Europe to develop their offerings and demonstrate them in space and put them on the market to provide services. So indeed, our role is really on the supporting of technology development side and supporting in-orbit demonstration of the technologies. But I think we have, at least for, I can say, for CubeSats in the agency, a growing portfolio of missions. Not only with in-orbit demonstration with our GSTP program, but also in telecom we have the ARTES program as well, which is launching a lot of technology demonstration small satellites. But also we have an expansion of CubeSats and small sats in the agency for operational missions. So for instance, the Earth observation program is now starting up the Scout mission, which is a small constellation of CubeSats for Earth atmospheric purposes. So I think what we're starting to see is, yes, we're playing dual roles in the agency vis-a-vis the sector. So as I said, on one hand, it's technology demo and demonstration, but we're also needing to procure transportation services as well for these missions, and it's a growing portfolio of missions. So we will have future growing needs for, let's say, being a potential customer for companies that are offering in-space mobility services, particularly where we see missions where we need to have them operated in orbits that are different to where the main piggyback launch opportunities are with the big launches. And that's really where I think companies like Deorbit and others can help to get us into different orbits. I would say also, just to touch on another dimension, which is going beyond LEO. I mean, we see a lot of activity for small satellites in LEO being developed for commercial reasons, but there are also technologies being developed such that we're planning now deep space and lunar CubeSat missions, and going out there into to deep space particularly. We don't always have piggyback launch opportunities, let's say, to rely upon from the large launchers. So having in-space transportation services to the moon and deep space would also be very useful for the future. So I think we can act as a stimulus in the agency as well for the sector. So that more or less wraps it up as an introduction from my side. Thanks.
Thanks a lot, Roger. A lot more, I guess, to discuss, but that's what we're here for. I guess again, a reminder for everyone. We have more than 40 participants right now, so thanks a lot for joining in. This is recorded so that everyone who can't make it can also review it. But this hopefully doesn't keep you from raising questions, so please do so if you have any. In the meantime, I have lots of them, so I'll be happy to kind of moderate a little bit here. And I would like to start with one question, and I think maybe Stefano can start, has a good view on that. When we talk about in-space mobility, we are kind of, it's an extremely broad topic, right? It starts with basically onboard propulsion, right? This is what Impulsion is doing, and quite successfully, but this is just one part of mobility in space, right? It goes further to, I would call it, versatile launch opportunities. So electric upper stages or services that, for whatever reason, allow you to kind of bring or service the last mile needs, right, for satellites, right, to be flexible in their launch choosings and so on. But it's a one-time service, not yet kind of what the next step could potentially be in the future, which is really assets, moving around, providing services, in multiple services, with a single mobility asset. Let's call it, it could be, call it a taxi or whatever, tug, space tug, or whatever you want, right? But along this way, and in this whole spectrum, what I see is there is a lot of dynamics in what companies are trying to offer, right? So there's companies who initially proposed the service, but then, are moving towards more the launcher versatility aspects, or hardware aspects. And there's other companies that have initially started to develop hardware and then move into more of the servicing domain. And I think, Stefano, Deorbit has some kind of history of that sort, or maybe not. Maybe I'm mistaken, because that's an outside view. So I was wondering how you see that, how interlinked are those dimensions, or will there be in a future ecosystem, the company providing the propulsion unit, the company building, the electric upper stages, and the service platform, which is, more of a software company like Uber, right?
That's okay. I mean, let's be clear. Space isn't yet a consolidated market, and I think it's a great asset of new space company, but it's company operating right now in this moment to be flexible and to adapt to different market needs, because they change. I mean, let's be honest. I mean, the space scenario right now, we couldn't think about it like 5 years ago. I mean, we got a lot of new launchers, new space is exploding in the good sense. We got Starlink, we got SpaceX, we got a lot of increasing number of CubeSat or more satellites, new launchers, and it's continuously evolving in ways that are very difficult to forecast exactly. I mean, I wouldn't be the shoes on space analysts now, and that's a little bit. I mean, that's. I like the definition you gave at the beginning of space. Space is a natural resource. So what we are doing right now, all of us working in this industry, is trying to get the best way to use this resource, hopefully responsibly, but use this resource for creating some added value that could possibly be sold, that could possibly benefit some stakeholder, agency, or private customers. Indeed, in the orbit, we have always had kind of vision on going on space logistics. We were much more focusing on space debris at the beginning of our venture, because it looked like it was a big deal. And it is still a big deal, but it's going definitely much slower than was expected, because regulation aspects, because resilience of some of the satellite manufacturers and operators. There are many factors. So we were flexible enough to accelerate some aspects, such as space transportation, and to be cautious, be more. Change a little bit our tactics on things like space debris. So yeah, I mean, coming back to your question, which is basically how we see in the future that to evolve. Well, definitely there would be several needs to be addressed. Space market is still very much institutional. There's a lot of technology being developing right now, being tested right now, including propulsion, as you said. And this technology, this maturation of technology, would definitely bring new companies and new startups or existing large companies to evolve, test, and develop new business models and new services. And there will be, there will be a natural evolution. Some of those services will succeed, some not. That will depend on many things, not just on the soundness of the technology itself, also on the soundness of the business model, the luck, the conjunction of planets of things that will make some services succeed with respect to the others. I see, so I'm very optimistic in that sense, and I see that there will be a very good and evolution in the future. Although it's very difficult right now to understand exactly, okay, let's go that path. There are some roads that are clear, like that we will need logistics in space, because, I mean, that's the way we move between celestial bodies. And Roger before mentioned the moon. Absolutely. I mean, we are now learning how to move in LEO environment, how to transport things in LEO environment. Next step will be the moon, and then Mars, and then all the solar system. We will need to learn step by step how to make all those steps profitable and safe from a technology point of view.
Yeah, I can relate to a lot of things you just said. Especially that space is definitely not a consolidated market yet, and things are a lot of in the flux quite a lot. But in general, I mean, we're talking about an ecosystem of assets that are very expensive, very valuable, and they're just moving around with 11 plus something kilometers per second, right, in different directions, and that means that having a good grip and a good control on how they move and where they are at every and where they will be, is kind of essential in order to avoid catastrophic events. And I mean, we see that it is very difficult, right, to move a spacecraft from A to B. It's not just the propulsion system, that you need to have and that obviously needs to work. But also, there's a lot of things around the propulsion system that you need to, come together in order to have successful, missions, successful maneuvers, orbit placements, and so on, right? And I can see the kind of the annoyance of customers to deal with these problems, right? It's something you have to do, right? But it's not something you necessarily want to do because it doesn't create any money per se, the efforts that go into that. Maybe to a question to whoever wants to ask that, but where are we on the technological side? If you want to externalize mobility, right? You say, as a satellite manager, I don't want to care. I just want to move from A to B. Take care of this, please, right? For me, whoever wants my money. We are quickly going into technological needs. What is required in order to do that, right? I don't know, Adel, if you want to take this one, or Roger.
Well, I mean, I can certainly give my view on this one. I don't think there is an easy, immediate answer to this question if it was asked by a player right now. But there will need to be such an answer in the next few years, because the need is definitely there. I can speak about the technological difficulties around moving something from space, like providing mobility as a service in space. Yeah, let's put it this way: providing mobility as a service in space. First, you need to find and get close to whoever you're giving mobility to, which is not easy. If you look at space, like I look at it, full of assets with market value, the majority of these assets, if you take in the market value, are in geo. Right now, it's changing, but from a market value, geo is still bringing a lot of most of the money to the whoever have a space assets. Not space, not deep space, not LEO yet. It will probably change, but this is how it's happening. To find an asset in geo is not something very simple, because the amount of information you have about geo is not as much as we have about LEO, for example, just to take LEO as an example. So you need to find the asset, and finding this asset is not something easy. You can find almost any assets in geo, but not associated with a good price right now. I mean, you put so much effort into that. Then you need to do what I call at least some near-range navigation. You need to go there, go next to the asset that you provide mobility to. And going next to an asset in a safe mode is not something that is ready technologically point of view. Also, it takes effort, it takes navigation essentially, propulsion also, but not the technology of propulsion and technology of navigation that is available right now. They don't talk to each other very closely. They don't talk to each other in an autonomous way. And to do near-range navigation, stay next to an asset with the current offer of propulsion is also very difficult. So I'm just listing technological difficulties. And then the last difficulty I see, it's actually docking, robotics in general. If you want to provide mobility to an asset, you should not view mobility as just, I'll take the assets on Earth and I take it to space. I mean, this is one mobility, but the mobility in space is I grab an asset in space and I take it elsewhere in space, or I keep navigating in space. And there you need docking, you need robotics, and again, the missions that happen in this regard, I mean, you can count them in your hands, maybe 1 or 2 or 3 that we are aware of. So right now, if someone asks me the question you just asked, I'll tell him, let's sit together and build a mission for the next 3 years. And then maybe I can give you a little bit of mobility. I don't know if I answered your question. Maybe Roger has the wider view.
That's already kind of a good starting point. 3 years that you're giving here. We have a couple of not customers, sorry for that. A couple of audience questions that came in, and the first one from Jerome Wink. I hope I pronounce your name correctly. Is how does the panel see the decreasing launch cost impacting the trade-off between electric and chemical for in-space mobility applications? And I don't know, maybe Roger, you have quite a broad overview on at least the small set side with some at least gas-based and electric propulsion systems flying. Do you have a view on that? Is Roger still with us? Yes. Okay, maybe he has some troubles right now. Any one of the others wants to take a stab at that?
I'll get Jeroen's question. Hi, Jeroen. well, not only propulsion, actually, that's something we're asking ourselves, like even space systems, because I mean, we were for years since university obsessed to make spacecraft light, and you know, now we are ready to spend a lot of engineering time to make spacecraft lighter, but would that make sense anymore with that if the launch cost is decreasing? Maybe, you know, maybe we can just send still, I mean, satellites made of steel and just, you know, make them very simple so they're so cheap. And so indeed, the launch, the change of launch cost, the decrease in launch cost will have an influence on many trade-offs on satellite design. Indeed, propulsion, it's one of them, indeed. Although that would depend a lot of, probably will change more like mission scenarios. Like probably we would still be using electric propulsion for, I mean, at least from our point of view, for those missions that are not like, say, for those customers that are not in a hurry. So they can wait maybe months or years to the delivery of the goods and so on. Therefore, anyway, still, if your customer needs to go somewhere in few days, they still need chemicals. So, you know, there's a number of different trade-offs, but definitely the decrease of launch costs will influence a lot space engineering and spacecraft engineering anyway.
Absolutely, and indirectly, right? If the spacecraft design priorities change in terms of the capabilities, mass, and so on, traits, that does affect propulsion, right? If your spacecraft becomes heavier and heavier, you need, you know, more thrust capabilities in order to perform the same maneuver, right? There's a question from Kevin Neff. Do you see the space industry eventually kind of converging towards standard mobility propulsion options? So this kind of touches upon the question of standardization, and it taps a little bit into the question of whether we expect mobility in space to be some sort of a winner-takes-all scenario where the business models only close if you service the whole industry or a whole orbit at least, right? Or whether we see in-space mobility being it as a service or, you know, products or assets of whatever sort will always be somehow a, you know, diverse market. So yeah, I don't know if anyone. Not sure if Roger was able to join again. I think he's having some technical difficulties. Adel, do you have anything? Again. Oh, hi, Roger.
Sorry about that. I had an internet problem.
No worries. We're trying to figure out whether, you know, the domain of mobility in space, you know, providing mobility in space would be some sort of a monopoly thing where the winner takes all. The first one to offer it, you know, with a whole lot of, you know, investments and resources, just grabs the market and, you know, takes it all. Or whether there are forces in the space industry in general that inherently prohibit that and make sure that, you know, there is national or whatever interests, you know, that make sure that there is kind of some sort of balance in the industry.
Shall I go for that then?
You can. I don't know if Adel wanted to start saying something, but feel free.
Yeah, I'll just continue on the idea I started. So, so to me, there's one thing which is like defining what we mean by space mobility, because there are two things that I see completely differently. Placing an asset in space, it's one type of mobility, like a last mile type of mobility. And then moving around assets in space is to me is another mobility. Okay, so depends which one we're talking about. I'll talk about the second. Making sure assets move around in space the way we want them to move, like avoiding debris, chasing each other, formation flying, rendezvous, inspection, this kind of mobility. And there, to give a quick answer, I don't see any reason for like a winner takes it all, really, because of the sovereign aspect of this. I mean, there's so many countries, and that they want to have their own technology, their own ability. So why would there be just one or two major players that offer that? So maybe it's a quick answer, but I don't see a reason for standardization or winner takes it all. But then in terms of technology, what I see is what I see coming is a convergence of many technologies, navigation, vision, all kind of sensing, and of course propulsion, things like that. And I see coming some kind of subsystem providers that could make it to a certain level of standardization. I mean, you can have like a big standard of how you move to space, and you would buy it from someone that has navigation, that has the thrusters, the reaction wheels, and whatever other system, and that allow a certain space asset, spacecraft to move. I don't know. These are my idea of what's probably coming in the next. So no standardization in terms of winner takes it all, but also maybe some kind of standardization of how technologically it's being offered to the market. Roger, to you.
Thanks, Adel. Yeah. No, it's interesting what you said there actually about standardization. I think what you see in many industries, what we've seen before is that there are de facto standards created, right? So it can be that the first to market can define the standards, and then the others have to adopt later. And I think for in-space mobility, if we include as you say, the tug approach, actually a service provider going to rendezvous and dock with a customer's satellite to change the orbit and then release it again. There does need to be a certain standardization in docking mechanisms and so on, and any pattern recognition needed on the customer's vehicles. So I think that's an interesting aspect about it, how that is going to be going. I don't think there's necessarily a winner takes all, because as I said, whoever's first to market will define something, the rest will adopt it probably. But I do think there are, when it comes to propulsive capabilities, there are of course different technologies, as we know, and on our side we've been supporting the development of those. So of course, you can have electric propulsion where you have very large orbit changes, large delta V's enabled by electric propulsion, with tug type vehicles. But the low thrust means it does take quite a long time. So in that sense, customers that want an orbit change, maybe of a lower delta V type, but don't want to wait for a long time to transfer, they will be more interested in a chemical propulsion solution, let's say. So, and then I think even within that, there's also a segment probably of customers which don't really need huge orbit changes, but they just want to have their satellites dropped off somewhere near the orbit plane where the launch is happening. So that's the kind of near-term market part of it, where not very large delta V is needed, and propulsion systems like coal gas are still quite suitable. So in that sense, I think different companies are going to have different technologies. I don't think any one company is going to have all of those technologies and could provide different variants of their vehicles to provide a dominant force in the market. So I think there will be room for multiple players. That's at least the way I see it.
Thanks a lot for sharing that. One follow-up question for you, Roger, is that kind of pops up in my head is, I guess some sort of standardization, if it's just the interfaces, right, or communication or whatever, is definitely, and this could be, in docking mechanism, but even on a simpler near-term aspect, could be just interfaces to a propulsion subsystem, right? Is typically, if you look at other industry, driven by the customers, the users, right? They sit together and say, we want our suppliers to basically, kind of be interchangeable, right? Because it's good for us. So we are dictating, some sort of a standard. That is hard because, there's no consolidation, in the platform market, right? And there's a huge overload of, platform providers. This is my personal opinion, but there's at least a lot of players. So how do you see, is there a role for an agency like ESA or NASA or JAXA or any other agency in this discussion of, standardization, but also, kind of
regulation, you mean? Like
regulation to some sort. Yeah, thanks, Adel. Yeah.
I think, well, there is a role for agencies, government agencies like ESA or intergovernment agencies, as ESA is the case. But we, of course, you see that with communication, space-to-ground interface standardization and the CCSDS standards. Of course, that's been quite successful, and it does allow ground station networks to be interoperable with the space segment. So, and allowing multiple providers. So I think there is a role. Just one thing to note, though, of course, we do know that standardization as a process does take time, because it is a kind of design by committee type approach. So all the players have to be involved. And there have to be then several iterations, probably comments from various sectors. So it won't be something that happens in the near term. And I think when you look at the CubeSat standard, for instance, just look at that. That was something which came out very de facto from a university, and it led to a whole new industry, and seeded a lot of the new space players we see today. So I think that kind of natural evolution of a standard, if something is a good idea, it will take hold and other people will adopt it in that sense. So there are two arguments to it. Should it happen naturally? Should agencies intervene and manufacture something? Probably both are needed, and they can probably interact with each other. But ultimately, if an agency like ESA or NASA or whoever is going to be procuring services, there will have to be specifications in the contract at the end of the day to have the service provider or prime contractor to be working against, I think.
Yeah, thanks. I have a very practical question to the industrial kind of participants of the panel. Following on that, if you provide a service to another vehicle, how far do you envision to extend that service? We have been talking about standardizing mechanisms and docking and so on. But I mean, the question that comes into my head is, are you basically shaping your service to the needs and even the form, shape, and whatever of the asset that you're providing to? Or are you starting or planning to or envision to even go one step further and provide potential customers, with a docking mechanism of what sorts? You remember, the grapple that OneWeb has on their satellites, for example. Is that part of the industry that provides mobility? Or is that something that the platform manufacturer needs to, design, consider, and think about in order to then maybe at a later stage order a mobility service?
Both. Stefano, you start, so I can build up your answers.
No, I agree that both. I mean, we would love to provide, let's say, influence standards and satellite manufacturers, but of course, we both have different interests here, right? So that's actually a very good point, and I agree with Roger. I mean, the agencies can help at the beginning of this process, because very likely agencies would be one first customer, so anchor customer of some of the services. So as Roger said before, usually in industry, but that's in every industry, the standards come from the first people that implemented that kind of services. So so definitely agency can play a role on that, and that's going to be a kind of negotiation between, trade-off between we that provide the service and satellite manufacturers. As our approach, we like to, the satellite manufacturer to lead. At the end of the day, is the customer, so we need to serve its needs, basically. So we are open to discussion with them. We'll let them understand, let them tell us how they see it, and we adapt to themselves. Of course, that will be difficult to end up with a situation to have 10 different, 20 different standards to, for instance, to dock a satellite, to approach it, or to serve it. And again, I think that at the beginning, the first standards, the first people that would provide the service on a regular basis will kind of impose naturally this kind of standard. Okay. What do you think, Adel?
A very difficult question to answer, but I'll answer it indirectly. What are the forces that are driving some kind of standardization in this? Right now, it's not the client and it's not the supplier. Like if you see the satellites that are being manufactured, very little are being manufactured with the idea of I want my satellite to be serviceable. It's starting, but nobody's really thinking this way. When we're developing a servicer, so we want to offer mobility as a service, especially docking and life extension, as you mentioned earlier. We're building our solution to be compatible with 90% of the satellites that are potentially serviceable. We think we're there, but to be honest with you, the moment we sit and talk with a potential client, we just realized that, we need to, know each other. And as I said earlier, 3 years work together. But the drivers I see for potential standardization are insurers and regulators. When we try to ensure such operation, I'm offering mobility to X. So X want to be insured for their assets, and I want to be insured for my assets. We realize that there's a third party that is asking us, certain question. Do you have this? Do you have that? Tell me about it. So this is certain standardization more of a process than of a technology. And then when we talk to some regulator, space agencies that can, allow certain operation to happen, even if that's really, questionable right now. There's really no enforcement of law in space. But you see people like in France, for example, we talk a lot with them. There's a bureau called Space, I can't translate it, but Space Safety Bureau. And they're like building regulations, like docking should happen like this, mobility should happen like this. You need to have this, and that. But in reality, if you go register your service or your satellite in, somewhere else, you can do what you want. But I see these two drivers for standardization there, not coming from the client or the supplier, but pushing the whole industry of mobility to a certain level of common regulation. This can be done, not this, but more driven by safety and insurance than about standard of technology. This is my view. Yeah.
Thanks a lot. We have a couple of audience questions that fit together quite nicely, because we have first a question about how things can be demonstrated in space. We've had the point from Adel saying that basically insurers, and people who will look at qualification status of any technology, especially if that's as dangerous as moving together, are very influential to mission and eventually spacecraft designs. We have Alexander from Germany asking about the need for a deorbiting system, right? So is deorbiting as a service, is also kind of coming from a regulation side, and I mean, the answer is yes. We see more and more regulations, more and more push. I mean, just ourselves, just providing the integrated propulsion system, we see a lot of use cases where people are including propulsion for that reason that, would in previous years probably not have cared about it, right? So there is this push. We had another question, whether we see actually a large push for operators to push for design for serviceability. So that kind of fits all together to me in a meaningful way. We have regulations and influential operators or their insurers, right? Trying to maintain a high level of reliability in space assets, right? Even in the new space era, and I think that's very important to do. We have the question is how in an ecosystem where everyone wants to be first and everyone wants to develop something fast and quick, we are able to and in particular, as Stefano said, right? You want to be work towards the customer and make sure everyone has exactly what he needs. At the same time, you don't want to qualify your docking system, for 3 years every time you have a new mission. So I don't know if any one of the three of you has any views on that, how this conundrum can be resolved, and who should step up, and kind of be the first to make a proposal.
I mean, I can start. I think the regulator should get together and start drafting things because it's their role and because it takes time for such things to materialize. If I see what drives me as I'm general manager of a company, when I wake up in the morning, I don't think about standardization. I think about my customer, what my customer needs. And if I take, slightly more risks than what is tolerated, well, that's part of business and that's part of technology and startup and space. And so I don't see that coming from clients or suppliers, but maybe when there are enough operations happening or happened already in space mobility and in different ways, whether docking, no docking, deorbiting, transferring orbits, things like that, there will be a common understanding and enough agreement and enough committees, as Roger Walker said, to draft some kind of standards that apply to all. But the work needs to start in that regard. If we don't want it to be a jungle, which it is already.
Yeah, I want to extend quickly what Adel said. Like again, I think we are witnessing a very dynamic market right now. So what happened is that everyone is very busy to make our customer, our investors happy. So we want to demonstrate our technology, our service as soon as possible. And we don't. I mean, I was about to say we don't see standardization or other kind of things as a priority. Which it isn't true, but let's say we are very busy in doing other stuff first, and we will get to a point where transportation and the mobility market in space will be consolidated. I will be very busy in starting thinking at standardization, debris removal, debris management, space traffic management, all these kind of things. But as rightly Adel said, I think regulators must be ready for that moment to come. When the industry will require in order to expand quickly that that standards or that regulations to be in place, we will need to be ready.
Yeah, perhaps just following on to that from what both of them have said, Stefano and Adel. I think, of course, coming back to end of life deorbiting, this is an important issue. LEO is a finite resource, and we have to act sustainably. And in the agency, we do have ECSS standards that are applicable to all our projects for space debris mitigation, and we have to comply with those. This is an important issue also for the small sat industry, particularly constellations. There will need to be end of life deorbiting if the altitude is too high with respect to natural orbit lifetimes being greater than 25 years, which is the current international guideline and ESA standard. Yes, I think there'll need to be a deorbiting capability on the small sats, unless, of course, in-space mobility providers would be there to actually do the deorbiting as a service, let's say, and in which case the small sat constellation would not need to carry such a large amount of propulsion for deorbiting. So that may be a business case, but of course, as we've discussed, I think the point was mentioned previously that safety and reliability is also paramount. So there is a role, I think, before going to space tug type services, including deorbiting, that the rendezvous and docking is demonstrated safely through in-orbit demonstration missions, and insurers and regulators can see that those that are actually offering services on the market are doing that in a safe manner, and we don't end up with actual collisions between chaser and target spacecraft in orbit. I think this is another important point. So in order to get going, I think there does need to be some in-orbit demonstration missions actually successfully demonstrating these capabilities, and that will help to serve the market and get it going. But overall, there will be a need to have this deorbiting capability for many constellations, I believe.
Yeah. Thanks, Roger. I agree with you. I think you have implicitly asked the question that just came in from Kieran Stephen, asking whether the launch cost, the decreasing launch cost, would make a servicing uneconomical. And I think we need to look at this. It's just one aspect of it, right? The one is the kind of first initial orbit racing, right? Yes, there is the trade-off, obviously, between different propulsion technologies, mission scenarios, and the launch, versatile launches, and so on. But then there is collision avoidance, right, which you mentioned, which is something that needs to happen fast sometimes, right? It's not something where you can wait for someone to come and pick you up, right? So you need to have a fast response of some sort. And then there's obviously the orbiting, that's it's being more and more regulated, for the good of everyone, I guess. We have discussed for an hour now, and I just wanted to quickly remind everyone we are recording this for everyone who has not been able to join so far. So if you missed the first part of it and you've just joined, feel free to go back to the beginning and revisit it. We'll have that online soon. Thanks for the many questions that are coming in. We'll keep discussing for about a half an hour with the questions coming in, and I have some of my own. So just a quick reminder that feel free to post something in the chat, and we'll get to that then. I would like to get back to one topic that briefly came up and then kind of disappeared again for other arguments' sake. that is the topic of demonstration in orbit. It was raised by some of the audience, and we have touched upon it in the beginning statements a couple of times. So demonstrating a mobility, an in-space mobility service is extremely hard, because you either service yourself, right, which is costly, or you service someone who needs to take the risk, right? And both is not easy, I guess, to achieve. I don't know who wants to start. There's the aspect from agency, from Roger's side, of course, being facilitating a lot of these demonstrations. But are these demonstrations missions, like the COMEX mission, where you basically fly in a formation, between two ESA-built or ESA-funded spacecrafts, or do those demonstrations also extend to interactions with commercial assets, right, and things like that? Or is that something that just industry has to deal with, by itself? How does that work?
Yeah, so I think it's good to mention at this point that on the ESA side, we do have we had a call out on our open space innovation platform for a possible commercial service for in-orbit servicing, and let's say that's something which can be or is being actively considered by the agency to stimulate also the market. So if we have an asset that needs to be serviced, proposals can come in to how for providers to how they actually then would service that vehicle. And of course we have the ADRIOS mission funded in the space safety program as well for active debris removal. So that will be a demonstration mission also for downstream commercial services. So I think there are the classical in-orbit demonstration missions funded by the technology program and so on, but there are also customer pull type opportunities for service provision, let's say, actively being considered in the agency.
Adel, how easy is it to convince a commercial person to dock to his spacecraft?
Next to impossible. Very, 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 very difficult. I think our approach is a infinite orbit approach, and I definitely don't have like a general answer there to that. It's a big problem. It's going to be a big problem for many things in space because of the intrinsic type of the industry. You need to launch things, you need to take certain risk, and then you demonstrate. So an in-orbit demonstration is going to be hard. There are not enough ways to do that. There are efforts from ESA and from other agencies to help in that, but definitely not enough. And when it comes to commercial, I mean, even less. Our approach is to demonstrate pieces of technology and kind of try to do missions that are half and half, half commercial and half demonstrate something while you're selling something else, and advance a little bit. It's maybe commercially, business-wise, very sound, but from a technology point of view, is not very optimal because it just takes time, and you cannot do everything that you want. That demonstrate docking is still like an unanswered question. Who would take the risk? What happens if something wrong happens? Who would pay the money? I mean, it's not. And docking, in my opinion, is like a space rendezvous in general is something very fundamental to the mobility in space. Very fundamental. If you want to offer mobility, you need to master this. It needs to be something very standard. We go, we dock, or we stay next to a satellite. And for that to happen, so many missions needs to go there, and so many technology need to be demonstrated many times. And somehow I don't see that happening very fast. So it's a bit of a difficulty for me.
you're touching upon a very interesting point, which is the kind of responsibility point, right? If you dock with an asset, something goes wrong, whose fault is it? I mean, we can't even figure that out for cars, right? And there the technology is basically ready. And still we can't agree, at least here in Europe, we cannot agree on, whose responsibility a crash is. Is it the car manufacturer or is it the driver who is not actually driving, right? So, I mean, there's a lot of progress, yeah, but still, at least if I take the car example, I see legislation, and regulations following technology and not the other way around, right? And I'm wondering if that's if we can or should expect the same in space, or if we can even afford that, or if it needs to be the other way around in space. So first have regulations and some sort of standards before anyone would engage in real commercial activities. Right?
I don't. Yeah, I mean the parallel is interesting, but I think it stops because there is not enough operations of such thing in space. On Earth, the car industry, to use your example, is managed by the insurers, and in some places, insurers just agreed that if in this area in Paris, an area that I know, an accident happens, then it's just 50-50. We don't think much about it. It's just 50-50 because it's too difficult to say whose fault it is. In space, there are not enough operations yet happening to be able to get enough knowledge and to point responsibilities and things like that. So I don't know, we're probably going a bit out of subject, but it's I don't see that happening in the next few years. I think it's a big technological risks, and depending on commercial needs, some companies will take it and some others won't. But definitely no major insurance happening there.
I mean, the situation becomes a little. Oh, sorry, please, Stefano, if you had.
No, I actually just what I was going to say that I actually like a lot the parallel between the automotive industry and space industry, and I personally think that space industry right now is quite similar for many aspects to what was the automotive industry, like 100 years ago at the beginning of the automotive area. And like, imagine, I mean, at the beginning, I think since, I mean, you're obliged to insure your car like since 50 or 60 years, which is not that much if you think about it. And before, cars were not insured, and that's a little bit the same in space. And I think, I mean, the approach we are taking here, like we are lucky. I mean, we have the possibility to launch regularly, so to demonstrate a lot of technology. And so in every annual launch that we spend to space, we test a small building block that will give us closer to the next step in the technology roadmap, which could be, for instance, in orbit servicing. And that's our way to convince customers, because indeed their first concern is reliability of the service and safety. And we want to convince them just by fact, like, hey, we demonstrate that in space. You may like it or don't like it, but I mean, it's safe, it's reliable. So if you don't like it, let's go next step. Or if you like it, okay, fine. Let's see how we can collaborate. So I think a lot that industry can contribute a lot in taking that risk. But after all, I mean, industry, especially in this big expanding wave of space industry, we need to take our risk and try to, let's say, to survive.
Absolutely. Roger, you wanted to say something, or?
Yes, I did actually wanted to mention one thing, which is indeed for in-orbit servicing, of course, going for a rendezvous and docking, that is a risky endeavor, and any customer who's thinking of procuring a service, as Stefano said, will be concerned about safety and reliability of the servicing system. So I think it is fundamental that we do have demonstration missions. I think there is an opportunity with CubeSats to actually do such demonstrations, and we have planned to we do plan to have the race mission, an IOD mission, which should demonstrate rendezvous and docking of two 6-unit CubeSats a number of times, so demonstrate the repeatability of that process, and also demonstrate close fly-around maneuvers as well, so that a target or a chaser flying around a target with a keep-out zone of only 10 meters, with all of the relevant sensors and actuators and so on. So that's something we plan to do as a major de-risking for these types of close proximity operations, and actually a major challenge in that development is the safety aspect. So being able to actually trigger collision avoidance maneuvers in the case that the chaser is getting too close to the target and is on a collision course accidentally, to then actually move away. So this is the next hurdle to be overcome, really, for New Space being able to offer such services. I think for the future, it's actually flight safety, and a large part of that is software development, of course, in the GNC system, but also fault detection and inspection and repair and so on, and being able to demonstrate a reliable and repeatable and safe service ultimately. So we tried to do something at low cost with the race mission, and hopefully that will lead to something later on, and that can be exploited by the industry commercially.
Yeah, it's interesting. I mean, we're seeing the kind of pure demonstration, right, of these technologies that you just mentioned, Roger, and we see the huge, that an actual commercial interaction between a customer who wants to be moved and the servicing to be probably a little bit farther out. And I'm wondering, so based on discussions we had in last week, whether there is maybe an intermediate step where you don't demonstrate the technologies, these kind of close proximity operations as a pure technology demonstration, but you include them in one single mission architecture, right? So Roger, you mentioned, I think in your previous talk, this kind of mother and swarm, engagements, where basically you have an architecture where the mobility providing entity, whatever it is, whether it's a carrier or some other, deorbiting whatever thing, and the functional units are designed together, right, as an architecture, because then it's much easier to ensure the whole thing, to operate the whole thing. You don't have these maybe these hurdles. So my question is it possible that this is kind of an intermediate thing we can expect in the next 5 years, maybe, before then, 5 years later we're coming towards actual commercial interactions in that domain, or is that too optimistic?
Well, I think the whole swarm formations architecture is really yet to be demonstrated. And however, there are, as we've seen from studies that have been done, there are some very interesting mission applications which do involve, architectures consisting of a mothercraft carrying smaller satellites, deploying them and acting as a communications hub back to the ground. So I think I would see it as a kind of side spin-off business, let's say, for those doing in-space transportation type services. And the mothercraft or the tug type vehicle could carry part of the payload, and the other small satellites which are deployed and linked to the carrier vehicle via inter-satellite links could then be carrying other parts of the distributed payload. So actually having formations of more than 2 satellites is really yet to be fully demonstrated, but there are applications, particularly in radar interferometry and optical stereographic imagery and so on. So I think it's worth an area to explore, and we may see technology evolving particularly with the propulsion side, with the very fine control cold gas systems, 6 degree of freedom systems, which we have in development in our program, combined with inter-satellite links, RF metrology to measure the baseline between the mother craft and the daughter craft, let's say, and combining that with the payloads to perform interferometric processing on board the mother. So there are a whole gamut of technologies coming together now, I think, where we might see that in the next few years.
I super agree with Roger. Actually, it's our next challenge. Like, once, you know, while you're transporting things in space, and once you have transporting things in space, what do you do with that carrier, with that mothership? That's a lot of additional service. We call them advanced services, by the way, that you can do to serve, you know, both the spacecraft you just released and other spacecraft. And yeah, Roger, your vision is absolutely right. At least it's one we think it's right that we need to follow.
All right, all good points that we discussed so far. I would like to kind of, before we close it up, I would like to kind of ask, again, you know, if anyone else from the audience we have, thanks again for sticking out with us. If you have further questions, please feel free to post them in the chat. If I overlooked something, you know, please just, you know, repost it, because I might have, you know, overlooked something that was posted. The kind of last round I would like to start is maybe a little bit on the business side of things. So we mentioned, I would think, you know, an hour ago, maybe, that we don't have a consolidated space market, obviously, right? And companies are still, or a lot of companies are still kind of agile, you know, and pivoting towards, you know, the market needs. And that's quite natural, I think. And there's a lot of consolidation going on all levels. But when we talk about mobility, and just as a reminder, we said there were three kind of, you know, types of mobility. There was the the onboard propulsion unit, which to me is an existing market, right? And we are supporting the needs there, obviously, as Impulsion. But then there is the part where we see mobility as a versatile or an extension of launch services, right? The last mile, the space tugs, Momentos, and all the that was on this discussion last year, you know, and all the others that are providing that service. That seems to be a very dynamic thing. I don't know, Stefano, if you want to say something to that, but it seems to be dynamic, but, you know, existing. And then we have mobility as a service, a pure in-orbit service that is still a little bit out there. Is it true that we are in this kind of middle stage now, where the market of, you know, moving things kind of in the right position is consolidating itself, or is kind of, you know, maturing, you know, before we then move further? And if you want to venture a guess, you know, the panelists, with all your experience, when will we see, you know, a taxi app in space to call for an Uber, you know, and in order to remove a broken satellite or something like that?
Okay, too many guesses. Yeah, let's start for this last one. I think actually pretty soon. I mean, we are very ambitious. So if I would say that we will be able to do something in that direction definitely before 2025. But I mean, many things can go quite quickly. I mean, look at the market we're operating right now, like transporting small CubeSats and so on, and the small satellites. I mean, that was pretty quick. I mean, we started last year. We already have several competitors like Momentus, Space Flights, and they are all demonstrating their technology. And things are going pretty quick. When a market is there, it's again, things can go pretty quickly. So I'm pretty optimistic on that. And it is true that it doesn't look a consolidated market, but there are consolidated needs, as Adel said before. And needs for orbit logistics, transportation, mobility, that's definitely a need. We just need to figure out how that will translate into practice. There are many declinations. We are all going in, different but same direction. Like Adel is going geo first because that's a big market, obviously. We are starting from LEO and then moving towards different kind of things like advanced services, as Roger said, and so on. So we are all trying to find a way we think will come first, but that will come at some point for sure.
If I can go for next, sorry. I definitely see some sort of consolidation happening in the business, but not that much. We are so collaboration is key in space. And space is big. We're not like IT or .com startups. We're chasing things that are big, risky, capitalistic, unregulated, so many things. So in order to achieve one of the things that we're trying to do, space mobility as an example, we need to work with so many other people. If I take the Space Rendezvous, we developed the GNC, the navigation, but we definitely don't have the propulsion system. We don't have the bus. We don't have the launch. So you need to work closely with so many people, bringing so many pieces of the puzzle. And I think it's fair to assume that once everybody has tried these things in the next 4 or 5 years, where services start to materialize repeatedly, that there will be consolidation. There will be like big organization, like taking all these pieces from different startups and offering mobility as a service. There won't be one, there will be many, in my opinion, because the market is there. The big question I don't have answer to is when. Is that 3 years, or is that 10, or is that somewhere in the middle? I hope it's 3 to 5, not 10. But that depends on so many externalities. So I really can't give better than just my best guess.
Thank you. Roger, will it be 3 or 10 years?
It's difficult to pin down a number, I must say, but I would just comment that it very much depends on the maturation of the market and the market size, and to a certain extent, let's say if the market is being driven by small sats and CubeSats, we've yet to see really, apart from a couple of companies, of course, big constellations of CubeSats being fielded in LEO. So there are some, of course, companies in Europe building up their business case and attracting funding to field constellations, and there are others worldwide doing that, but they've yet to be launched. And so in that sense, it's a little bit unpredictable. It's very unpredictable right now what will end up as a mature market size in the end. And I think we won't know probably until 3 years or 4 years time at least. And then there will be a lag beyond that for the in-space mobility or in-orbit services, if you like. So I'm a little bit more sort of inclined to say on the longer term for the actual servicing or mobility market, it will have to wait for the shakeout of the different constellations first, which we won't know until 3 years at least, I think.
Yeah, thanks. Thanks a lot. I think Adel had a very good statement there in the last round, which is collaboration is key in our industry, and I think we can all agree on that. It's we are fortunately, and I personally enjoy that very much, in an industry where with all the technological, and now also commercial competition that's going on, we're still, everything is really a lot based on exchange and collaboration.
Mhm.
And I think this is, one of the reasons why we're having this panel, or we had this panel, and we're trying to foster this exchange in the domain of in-space mobility. I think we are at a good point to end the discussion. 90 minutes, I think, it's a lot of discussion already happening. Thanks so much for everyone on the panel. Adel, Roger, Stefano, thanks for meeting with us today and sharing your views. Thanks to the participants. I think we had a very nice turnout and a lot of questions, actually. I hope we could answer most of them in the discussion. And I think we're in exciting times. I think we are in. We'll see a lot of development in space mobility in the next years, just comparing last year's panel and this year's panel. So we'll keep that up next year, hopefully in person. Let's see how it goes and what has happened in the meantime. So thanks everyone for joining. Thanks the three of you, and I hope to talk to all of you pretty soon.